to this talk for our event. As I said, the first seminar in this year of our energy finance series. Let me introduce Jutta briefly. She is a professor of business administration and production management at our university, so the University of Duisburg-Essen. Unlike most of us others taking part in this energy finance group, her office is not in Essen, so she's in Duisburg, campus Duisburg, and she's at the faculty of the engineers. So it's our even more pleasure to have her here and to listen to her talk. And right, so very well prepared. Maybe Jutta, you will say something on her sort of academic career herself. And I think I'm going to stop now. The talk finally will be on multi-criteria analysis for energy management. And so Jutta, the floor is yours. It's our pleasure to have you.
Yes, thank you very much, Rüdiger. Thank you so much for your invitation, and I'm very glad that I have the opportunity. I would have loved to come to Essen, although I'm living in Mülheim, and my office is in Duisburg at the most western part, I would say, at the university. I think the campus in Ruhrort is further west. Yeah, I'm at the faculty for engineering. That's a little bit specific. We have there the Institute for Industrial Engineers. And we are teaching the industrial engineers, we supply them with knowledge about business administration. Beforehand, I was for 12 years professor for production and logistics at the Faculty of Economics at the University of Göttingen. But I'm very motivated now to work again with the industrial engineers because I studied that in Karlsruhe in the last millennium and did my PhD and habilitation there. I'm coming back to my roots because I did my bank apprenticeship in Duisburg long time ago. But I'm here today to talk about multi-criteria analysis for energy management, and I would like to explain that or elucidate that with a case study or a project which I have started already in Göttingen. And Göttingen, it was for the Bundesland Lower Saxony, north of North Rhine-Westphalia. And the project was a big one with colleagues from 10 different chairs from psychology a bit, but a lot of electrical engineering. And the task was the development of a process for integrated development and evaluation of energy scenarios for this country, Lower Saxony. We started in 2015, and we were considering transition paths to sustainable power generation in the year 2050. And the overarching research questions of the whole consortium was what are the different possible power generation systems in Lower Saxony in the year 2050? What makes a sustainable power generation? By which can we distinguish that one supply is more sustainable than another, and this for the long future? And how to plan this long-term transition? And our task of my research team was how to evaluate not only the final system in the year 2050, but also include the intermediate configurations of the power generation system within the evaluation. So we would like to know what's going on in the next 10, 20 or 30 years. And the research question, so to speak, was the consideration of temporal interdependencies and how to do a multi-criteria evaluation. We have written, I like this paper very much, therefore I can say a nice paper on the combination of scenario planning, energy system analysis and multi-criteria analysis. And I can supply that for you. Likewise, I will send you the slides as well after the presentation. The whole project report is this year and it's edited by Professor Engel and other colleagues. So today I streamlined the presentation on the multi-criteria part because I would like to present you my way of working, which method we apply, and how we have done this in that project. And I would like also to give a small outlook how we further develop these methods. I skipped a little bit the long explanation of scenarios because I think you at the School of the HEMF, I don't know how to pronounce the abbreviation of your school and group, knows that very well, how scenarios can be designed or would be designed. And let's take it for granted that we have different scenarios by which we can develop the energy system, and these are made up of the power grid, of the topology of the distributed energy resources, how much digitalization we would have in the distribution net, what kind of energy management do we have? Do we have the energy mix as today to compare it with the status quo, or have we full renewable energies or some backup fossil power plants? What is the demand for energy in the households? Will that change? Will they be very open to new technologies? What is the economic structure? At that time, we were speaking about growth and gray stagnation. We had nothing like the Corona crisis in mind when we did the project. And the levelized cost of electricity, intentions of energy policy, politics, knowledge and perceived control, and the acceptance by the population. We had a big debate on that and came up with possible states of the future and tried to model these different scenarios. But then the question was, what is a sustainable electricity supply? By which factors can we distinguish that something is more sustainable than something else? And we are speaking about the sustainability dimensions, the environmental sustainability, the economics, sustainable and social aspects, but also technical aspects. I must admit that in all my projects, we are not successful to divide the technical aspects to the other three as the three pillars of sustainability. We always have some technical aspects that we have to take into consideration. And so my method of choice is multi-criteria decision analysis, because in my decision problems I'm dealing with, we have different criteria that we have to take into account, which come in different units of measurements, which are incommensurable, that we cannot convert them all into meters or euros. We have to deal with that they come up in different units. And so information on all these criteria was collected in this project, in the sub-projects by the other project partners, like investigations about behavioral adaptation, how could a smart home be, or the smart grid, how is the sustainable network expansion and the energy mix. And that was being evaluated by a life cycle assessment to collect environmental key figures, and the macroeconomic modeling supplied us some economic criteria. The data came up out of a big energy system analysis model. It was a big combination of many models. This is being done by the office in Oldenburg. They collected that. We had some micro-level models, macro-level models. We take into account uncertainties and quite a lot. And I'd like to skip that because to explain that would also use 1 hour. Hello, Christoph. So the decision table we're dealing with is, again, here we have the criteria, the different 14 criteria, I would say, the different unit of measurement. And this is a typical decision table. We have the alternatives that we take account, and I'm going to calculate an example with you with 3 alternatives, which we evaluate against this set of criteria. Not so good prepared here that I can't see the next slide so much. So this is basically the decision table, and you can see here that we have distinct alternatives. We can call them 1, 2, 3, or 7, or 18 we could do, and therefore coming to the selection of the methods, the multi-criteria decision analysis is a subgroup of operations research. And this falls into two big families. The one is multi-objective decision-making. And here we have the alternatives are restricted by constraints, and we have a continuous solution space. So, and we speak about vector optimization, or other expressions are goal programming, and we have two or more goal functions. And we can first, in a first step, we define the Pareto frontier. We find out the Pareto optimal solutions. These are the solutions which are all good, and we delete the dominated solutions, which are dominated. They are worse in some aspects than the others, and then we have the choice problem between the Pareto optimal solutions. But this is a method for the continuous solution space, where we have somehow mixing problems or so. But we have discrete alternatives or discrete solution spaces. We have sets of techniques of the different alternatives, and we have to choose something of that. So we have the criteria, as we have seen in the previous slide. We have the alternatives, and here the performance scores, and have to find a solution. The theory on multi-attribute decision-making falls into two schools, so to speak. We have the classical approaches are being called the American school, despite the fact that this has been invented in Germany. It was Mr. Zangemeister with his diploma thesis on Nutzratanalyse. It's the utility value theory or analysis. And other approaches are the analytical hierarchy process. And they come up with a complete order and fixed utility values. And this comes with compensation, as a complete compensation that the weaknesses of some alternatives can be outweighed by the strengths of others. And we have the full compensation. And that has been criticized in the 1980s by some researchers from Paris and from Brussels. And they have developed the outranking approaches, which are being based on pairwise comparisons, and they also allow for incomparabilities and weak preference. And I like that idea because I think it's more realistic if we are dealing with environmental questions, or if we are comparing techniques, because sometimes we cannot mix up everything. And there has been a strong debate which methods is the best. There are heavy debates at the multi-criteria conferences. It used to be. I think it's very interesting that at the moment there seems to be it's emerging of a common approach to that. I can send out also some recent papers which stress the communalities, the common things between the approaches. So my method of choice, I like to work with primacy, because I think it's flexible and very well suited in the context of sustainability. I haven't brought the mathematic description for that. That would have been perhaps more appropriate for the colleagues from the economic department in Essen. But it's easier in the evening to understand it with a simple example. So we have the decision table, the matrix, with the information about the criteria and the criteria scores. And the pairwise comparison is that we compare the three alternatives for each of the criteria, for each criterion. So for instance, raw material consumption in tons. First, we have to think about what is good. Do we want to have as much consumption as possible or as little consumption as possible? As little, we want to use as little as possible. And therefore, we compare these alternatives. And this alternative 2 needs 4 units more than that. The difference is 4. And therefore, the alternative A1 is better than A2 because it's using less. And with this preference information, or vice versa, the alternative 3 uses 8, this 10, so it's by 2 units better than alternative 2. And this difference in consumption of 2 tons, so to speak, is being translated with the preference function into a dimensionless figure of preference. So we have a total preference is stated here in this case. It starts if the difference is higher than 4. And if it's 0, then the preference goes down to 0. But if it is 2, according to this function, it's 50%. It's a weak preference. It's slightly preferred alternative 3 over alternative 2. And we do these comparisons for all the differences in both directions. So if you look up, what is the comparison between A and 3, then it's -2, and -2 is here, and therefore it gets 0 as a preference value. The trick in this approach is that we have the comparisons are not mirrored, so they can be different, and we don't have the same or the -1 of the upper triangle matrix. We do these comparisons for all criteria that we have in the matrix, and then we can calculate for each criterion and an aggregation, the positive outranking flows, which express the strength of an alternative. We can see how often alternative 1 is better than the others. Of course, this is always 0, but this is being summed up and it's denominated as a positive outranking flow or the strength of the alternative. And these figures are first multiplied by the weighting factor. How important is that? 1/3, this 1/3, that 1/3, and then it can be summed up. And the sum is then the outranking, the positive outranking flow. Likewise, we can calculate how often an alternative is dominated, how often it is weaker than the other. And this is being expressed as a negative outranking flow as a measure of the comparative weakness of the alternative. And we can also calculate the net outranking flow as the difference between the strengths and the weaknesses. And based on that, we can have a complete ranking. I'd like to show that in this example. We have here, for instance, we have from the pairwise comparisons regarding the four sub-criteria, technical, social, environmental, and economic, we can see how much strengths we have, which weaknesses we have, and the net flow is the phi plus minus the phi plus minus phi minus is the net flow. According to the net flow, we can have a complete pre-order. We can see here that this alternative has the highest net flow, so this is the best, the second, and the third. We can also have a partial pre-order, and for that, we have first one order according to the strength, so this is the best, the second, and the third. And then we'll have another order according to the weaknesses, so this has according to the weaknesses, so this is the best because it has the lowest weaknesses, second, and this. And then both orders are being brought as an intersection, and by that we can have incomparabilities. We can have indifference, that both have the same value, but we can also have incomparability, that we cannot compare these two or that. Here is not a comparison possible. And this is somehow a philosophical question. So the American school, they come only up with a complete pre-order, and you have a strict ordering what you have to do. And the outranking approaches, they have a closer look of that, and they see contradictions in that. And it's sometimes difficult to interpret that. And some decision makers say, oh, that's too much for me, just simply tell me what I have to do. But I think the result, it depends on the alternatives that you compare with each other. And we can see that at the example later. So for our case study, we compared the planning of the transition of the power generation system in Lower Saxony. The objective was to find transition paths towards sustainable power supply for Lower Saxony. And we considered 3 paths. The first path, Psi1, is Psi1 is a local power generation with flexible demand, and we have rooftop photovoltaics, for instance. So shortly speaking, it's a local power generation. Psi2 is a concentrated energy supply with large storage facilities and large-scale plants in order to use economies of scale. For instance, we use offshore wind parks. And Psi3 is middle ground. It's not the mean value or so, but it's taking something from all solutions and a different scenario which is being investigated here. We have the 18 criteria which are weighted on the upper level, technical, social, economic, environmental. They have equal weights of 25 for each dimension, and on the lower level, it has been distributed somehow. We take one exemplary scenario where we think about competitive conventional power plants and an untapped renewable potential which we are using. And we calculated that for 4 evaluation periods for every 10 years. So we would like to see here how the transition paths towards 2050 develop, and want to investigate how it might behave, and if an alternative which is quite weak over a long time can catch up later on, or what might happen there. So here a little bit more description of the alternatives, how they are being made up, but I think for our purpose today, it's not so important. And the basic idea is for the multi-period decision table that we develop, that we do the calculation 4 times and then try to elucidate the transition paths. Before we do that, I show you the decision table for the 4 time slices. And beforehand, I would like to show some results of multi-criteria and what the method can show for the example year 2030. For that, we did the outranking, and we developed a software, the Promethe Cloud, which is will be soon available for everybody. And at the moment, for testing purposes, we call it Promethe Cloud because it's open sourced and in the cloud. And for the 3 alternatives for the year 2030, we have the outranking flows by criterion. And I like the method because we have the stacked bar charts, and we can see here in blue color the technical criteria, the environmental in green, the economic in purple, and the social in red. And we can see here, this alternative, according to the FINET, comes off best, and this is mainly because of the economic criteria. Yeah, you can see the contribution to that. What is very important, the outranking is based on pairwise comparison, so it's only a relative comparison. All information is being made up of the decision table, and it's relative. The strengths of one alternative are the weakness of the other alternative. So if you sum up all the FINET values, you must come up with a value of 0, because it's the strengths of the one are the weaknesses of the others. How to come up with a partial and a complete pre-order. This is a very nasty example, I must say, and therefore I'm explaining so much about that. If you are doing a complete order, as it's said, it's the same figure as before, then it's easy. We have A1, A2, A3, A1, according to the FINET, the grade chart. If we have a partial pre-order, we go for the Phi plus, the ranking. So A1 is better than A2, than A3. But if you are going according to Phi minus, the smallest negative is this, A2, A3, A1. And this leads to the result that we can say A2 is better than A3, but we can say nothing about A1. It's jumping around somehow. Sometimes it's best and sometimes it's worst. And this comes to the conclusion it's not comparable to the other. And this is the enriched information that we have from the partial pre-order. What we have now developed is how to explain that and see more of that. And in our Promisee Cloud, we have the depiction of the Phi plus flows here, and see that alternative A1 has a lot of arguments in front of that. It has the highest arguments in front of that, but it has even higher arguments against that. It's somehow very much biased, yeah. And so we are thinking about how to elucidate that and how to understand such jumping results better. The next point is that we have sensitivity analysis to investigate that, and the weights and stability in the intervals we have here for 2 criteria. Metal depletion is easy. We can see here, regardless of the weighting that we choose, 0% or 100%, then the ranking of the alternatives remains stable the same. But a very sensitive alternative is a terrestrial acidification, a criteria coming from life cycle assessment, and that was chosen with 3.6%, so somehow here. And the insensitivity interval is that area where the ranking does not change. So we can change the weighting of this criterion between 0% and 10%, and we have the same ranking. If we change that higher than 10%, then we have a change on the rank level. So the green and the red alternative will change their position. And if we are higher as this, then we have a completely different ranking. So this is a very sensitive criterion. And I think that the method is helpful to focus the discussion on the critical points. And the Promisee method comes with a Gaia analysis. It's being called Gaia for the ancient Greek word Gaia, earth, it's said, and it's basically a main component analysis. And we can see here a screenshot, and this is a little bit more insight. We have the alternatives A1, A2, A3, and these rays here represent the criteria which are being considered. And we have the decision stick. The decision stick is the vector containing the weighting factors for all the 18 criteria. And this is somehow a projection from the 18-dimensional room into the 2-dimensional room. And we can see here, the smaller the decision stick appears, the more sensitive is the alternative. So the solution, the rank order. So it's jumping around very, very fast. And I must say, such a result I have never seen before. Normally, it's more even spread, or the alternatives are closer together. It's a very unusual result, I would say. Yeah, next, to investigate what's going on there, it's a sensitivity analysis. We can do a Monte Carlo analysis, and to change the values, we have 1,000 calculations with small areas of uncertainties. And we can see here from the box plots that the ranges are overlapping so much. So it's possible to see there a little bit more. I have stolen this picture from another investigation. So it might look, if you do the Monte Carlo analysis within the Gaia plane, and we can also have an investigation of this decision stick, in which area might the weighting change and how much does this area move. And for our example, I would guess that it moves around, and so we'll have a flipping result according to which weighting it goes into. Sometimes take alternative 1, then 2, then 3. It's just jumping around. It's very nasty. But I must say, I would say it's not a mistake or fault by the method. The method elucidates and makes transparent where the goal conflicts are, and it shows that the alternatives are somehow a little bit unlucky, infelicities. I have read this nice expression about that. It's perhaps not the mistake by the method, but it's the characteristics of the alternatives. Yeah, and our cloud system is approachable here, and we can have other kinds of sensitivity analysis like walking weights, which can be investigated. What we have done now I've told you everything about the promising approach. Now we want to know how do we do a multi-period evaluation. And we have split the evaluation into 2 steps. First, we have for each of the 10 years, 2020, 30, 40, 50, an individual evaluation of the decision table, but then is the question how to aggregate the evaluation of the alternatives along the transition paths. And so we have done a problem structuring and a notation for the transition graph that we have at the vertices, the possible alternatives with the different future states of the energy system, and the edges as the possible transitions between the 2 alternatives to depict the path dependencies. So if we build today a lot of power plants, offshore power plants, offshore wind power plants, we have to use them for 20 years. We cannot assume that we demolish them in 5 years again. That's stupid. And so the transition path psi is a set of the consecutive alternatives. For the scenarios, we have a certain mixture, and the pie charts depict the annual energy production and the energy mix. The gray is the fossil fuel, biogas is green, wind is blue, offshore and onshore, PV, of course, yellow, and ground-mounted PV in red. And we can see here that the composition of the energy mix is changing over the years, and this comes out of the results of the energy systems. And one path is for the Psi1 is the development of the local supply, that we have local power generation with flexibility management, like the A1 or Psi1 in the course of time. We have the concentrated one, where we can also see, according to the different consumption by the persons living in Lower Saxony, we have also a different demand. It changes between the passes. And for the middle ground, we have this. And then we calculated first for each time slice the phi value, the phi net value. I have shown you before the result for 2030, but we have done that also for the other time slices. And then is the question in the different periods, different paths are considered the best solution. So the question is now, which path is superior? And we have, we have here the calculation for 1 year. I've shown that already. And then is now the question, if we compare the phi net results, should we go for arithmetic means of the results over the different years, or could we calculate with the discount factor that we think that it's better to have savings today rather than later on? So we have the different calculations for the different years, and then the question, how do we come to an evaluation of the whole path? And why have we calculated with the 9.1%? We have seen that we've done a sensitivity analysis, the variation of the discount factor R with an enlarged view here of the intersection point at 9%. And we can see here, according to the chosen discount factor, the phi net value of these alternatives are moving closer together, or they are larger out of each other. So what have we done in the project? We started with a qualitative system description and did scenario planning. We have used the approach from Gausemeyer that has been used by the colleagues from the office in Oldenburg. And our focus was on the quantitative system analysis where we did the attribute quantification, the modeling and the simulation, and tried to do a multi-criteria analysis of the different passes and how to bring that together, to combine that. So it is somehow possible to think about multiple consecutive discrete periods with temporal independencies, but there are so many challenges and open questions. So we have to think about the past dependencies. Today's decisions will limit the future decision possibilities. And it was very difficult to grasp that, to understand that. It was very difficult also for the consortium to develop consistent scenarios where we take into account that solutions of today, or which are being developed in the next 5 years, how would they be, how flexible will be they in 10, 15 or 20 years. The performance of the alternatives is dependent on the decisions in other periods. And we have different kinds of uncertainties. The internal uncertainty, we have the uncertainty about the appropriateness of the assumptions that go into the calculations, and the external uncertainty in the scenario analysis about the environment and the related decisions, what's going on there. And we have to take into account preference informations from the stakeholders, but the stakeholders, every year they have different priorities. This is changing over time, and how could we take that into account? So the question is still open. We did our best. We tried to elucidate and supply as much multi-criteria as it is possible at the moment. But for further discussion, what are the research questions remaining? So how to evaluate not only the final system, but also include intermediate configurations of the power generation system in the evaluation. This multi-period, multi-criteria approach allows, via the transition graph, for the consideration of multiple criteria and the path dependencies. And the information for the decision maker is enriched because we can contribute the different periods to the path assessment. We could have the spotlight or the highlight of the different time slices. And the decisions and energy policy can be supported, and the results can be used to question why some alternatives come off better than others. Because in all my projects so far, the project consortium was very much fond or liking, they wanted to have the decentralized solutions. This was the hypothesis. Decentralized solutions must be much better than the others. And as a big surprise in my calculations, where the others delivered the figures, always a centralized power supply came out best. And then you have to think about, why is that the case? The simple answer is that it's economies of scale which are working there. But then you have to think, yeah, how could you make the decentralized solutions more efficient, or how could you utilize learning effects and improve that? Open questions are, what is the temporal preference? So concerning the duration of future performance scores. So are earlier emission reductions at higher costs preferred to later emission reductions at lower costs? This is an important question, and it goes surely beyond scopes of operations research. And the other question is, who are relevant stakeholders? I would also like to show a bit what we are doing. Also, we have at the moment a big project from the ministry. It's called SALAM. It's water strategies. It's transboundary strategies for integrated water resource management for solving the water deficit problem in the Middle East. So it's we have the project partner Israel, Jordanien, and Palestine, and how to supply this region here with water. And we have different regional strategies for water production and water transfer. And we have alternatives like seawater desalination, of course, at the sea, the water supply and infrastructure, the pipelines. We have the wastewater management and reuse and how to treat effluent and brackish groundwater in the region. And for that, we are also doing the multi-criteria decision support. And at the moment, we are still busy with cost estimation because this is quite tricky. And it's also a long-term multi-criteria problem where we have the combination of different solutions. And I would say that's somehow a question in the water energy nexus. And it's also my possibility to introduce myself, and I would like to get in closer contact with my colleagues at your faculty. And so it's Rückblick and Ausblick. In Göttingen, I was working at the Energieforschungszentrum Niedersachsen, Energy Research Center, Lower Saxony. And at the university, I was head of the and speaker of the research training group on resource efficiency. And I'm glad to be able in Duisburg to build upon my experiences at the French-German Institute for Environmental Research, where I worked a lot in Karlsruhe, where I worked on best available technologies in the iron and steelmaking industry and in surface treatment. So it was a lot with the car manufacturing industry. And I did a lot of life cycle assessment, and I'm glad that I can build upon this knowledge. And we have projects in the energy sector, building upon the project I have described, where we dig more into detail in the electric vehicle and the charging systems. And Marcel Lumeyer, who prepared this presentation together with me, digged deeper into the detail of electromobility to reach the climate goals until 2050. In the water energy nexus, I just mentioned the integrated water resource management in the Near East, Sebastian Scheer. We had life cycle assessment, also multi-criteria decision support for innovative harbor technologies with the harbor in Hamburg. And we do at the moment life cycle assessment and multi-criteria for the iron and steelmaking industry, Hüttenkrupp, Mannesmann in Duisburg. Christina Scharpenberg is active there. And with the preparation of slags from municipal waste treatment, it's Leon Zaharopoulos, who's also in the presentation. And we are awaiting a new project for life cycle assessment and multi-criteria. Isabel Wiemer, she's also in the audience. There we will be also responsible for the combination of life cycle assessment and multi-criteria decision aiding. And I would be glad to see some common points with you. And now I'm curious for your comments and questions. Thank you very much.
Right. So thank you very much, Jutta, for this very, very impressive talk, and more, and also as well for implications of further work and all you've done and we could possibly do together with our group at the HEMF. I'm sure there's some questions. So if you as a participant would possibly simply raise your hand, and Jutta, you may sort of take the questions and sort of, recite over the order of questions.
Oh,
okay.
I try my best.
Right.
Christoph, of course.
Perhaps I should have left to somebody else the first question. Sorry for arriving late. I was in a project proposal meeting, and it got interesting in the end, as frequently. Well, I really liked what I've seen. Unfortunately, apparently, I missed this part about the strategic placement of charging stations. So happy to hear a bit more at another occasion, or to get some, if you have some working paper or intermediate presentation. But I was wondering, with your time-dependent paths doing intertemporal consistent decisions. Have you thought about how to combine that with uncertainty that decreases over time? So seen as from today, we have huge uncertainty, for example, on the cost of hydrogen in 2040. And as time passes by, we hope to learn, and obviously in 2040 we will know about the cost. So there is also a kind of path dependency, and there are obviously techniques like real option analysis, which try to cope with or deriving optimal strategies in that kind of information discovery over time. Have you ever thought about combining this with your kind of multi-criteria approach?
I'm aware of the research real options, but I think that the uncertainties and the overlaps are already with these discrete assumptions are so big, the overlaps, there are so many overlaps that it's already somehow frustrating. And if I pull more uncertainties on that, the picture will be more diluted, or das Bild wird immer verschwommener. But likewise, yeah, we need to think about that. So we had really very much discussion about the discounting factor. I mean, even if you have a discount factor for the economic values for the euros, what should we take? And then we looked up the literature, what is the discount factor for CO2 emissions or for CO2 equivalents? And there you can see some papers which are talking about something like 9% to say. I must say here, we have taken the 9% to see where we have the become something equal. And so for 9%, the best and the second alternative, they become equal. We have just thought about that. And yeah, and if we I forgot at which point you entered the stage, but if we have just for the year 2030, we do the sensitivity analysis, so everything is coming up as good, and so much overlap. And if we do more overlap or more uncertainties, I think an open question for research is also how to depict that, how to interpret the results, or by which questions, or who is to decide what to do. I think we have to take a decision. Wait and see, so is something, do nothing. Or we go for one path or alternative, but we have, in our democracy, we have to declare why we have taken that decision. And if I would be the king of Germany and have to decide myself, okay, we have decided to go for that, although we know the other options are almost as good as this one.
Yeah, I agree with you that these are research fields on their own, and I'm not into all the details, and probably Rüdiger on some aspects of discounting, or Heiko Jacobs, if he's around, can tell much more than I can do. But I believe there is no straightforward solution, but it could be worthwhile reducing the number of dimensions, and think first conceptually and then in application about how to include these ideas of either backward induction of optimal paths, like we do it in dynamic programming, or think about what are we fixing if we take a decision right now, instead of applying a wait and see logic, and to combine that with multi criteria assessment. But are you aware of any work in that that goes in that direction, or?
No, I haven't followed the real option literature. Followed it. I would say, yeah, the big trend is towards multi-criteria, because the aspects of sustainability, or at least climate change, are so present in the debate that it becomes difficult that you do economic decisions or investment decisions solely with economic figures. But that's a very fluffy answer. But that's what I hear from every side.
Okay, I don't see any hands, so I take the privilege of the moderator to ask a question without raising my hand. So maybe a little comment first. I think in the climate change literature, there are people who are willing to kill in determining the right discount factor. So there's lots of arguments going on. My question would be more in the direction, say, if you have this multi criteria decision pool, would it be a possibility to include flexibility as a criteria, in a sense that if I sort of take a decision now, how much did I commit myself for the further future path, or if I take a decision now, how costly it will be, say, in 5 years to change to a different strategy, to a different path. Would there be a possibility to, in a sense, combine this sort of flexibility approach with the hard criteria, in a sense?
You could have somehow the flexibility as a soft criterion, or that you say the flexibility is high, middle, low. So this is nice with multi-criteria, that you can cope with any kind of criteria. Is it on an ordinal scale or nominal scale? This way you can deal with that. But how to depict that? So I must say that I'm mixing up two questions. One is the methodology, and the other thing is the application, where we are thinking about the development until 2050, which is so much in the future that we cannot know. 16 years ago, we hadn't had an iPad, we have learned, huh? And so we don't know what's around the corner, and yeah. Would be interesting to think about that and to integrate that, but I don't have a fast idea.
All right. Okay. So thank you. No, I want to get rid of my hand.
No, don't.
No,
will use it.
It came up for some reason. It came up, so it's I always experience new things working with a Zoom. So we've done it so often already, but it's yeah, it's a multi-action sort of device. Right. So are there any further questions? Any more questions or comments from the audience? Right. I don't see any currently.
I see Christoph. You are so polite.
Okay. Sorry, I'm also not using Zoom on too regular basis, so I was more rapid in raising my physical hand than raising the virtual hand. I was curious, you mentioned that, if I got it right, especially in your project for the Lower Saxony energy strategy, there was interaction with the user group. And so I wonder, what are your key lessons so far for when you use that kind of methodology with different types of users and try to elucidate actual preferences for the choices that are to be made collectively instead of one Queen of Germany or King of Germany making the decision?
Yeah, it was somehow a little bit frustrating, I must say, because we got luxurious funding. We had lots of funds, and we could have stakeholder workshops at the castle in Hanover, Schloss Herrenhausen. And but when to do that? Somebody of the ministry wanted to participate, and so we had the meeting on Monday morning or so, and who is coming? It were some housewives or so. I'm not allowed to say that, but who has time to come around? And then were some people with some funny ideas. Today you would say Querdenker. The expression was not yet around. And then there were people who are selling some fancy engineering spleens and wanted to have their special new invention, and they used this workshop to do promotion for that. And so we were wondering, what have we done in the wrong way? And on the other hand, I'm often encounter multi-criteria evaluations or questionnaires for preferences at some conferences. So we have a conference on biogas plants, and then there's a questionnaire somehow also biased. Don't you think biogas plants are the best? And so questions go all into this direction. And if you go onto the conference on photovoltaics, then it's all into that. So where can you get somebody who has the knowledge for everything? And you could think about the first reflexes and, let's do a Delphi survey or so. But to whom do you want to send it? Who is not the king, but who is the almighty person who has knowledge about all these areas and can compare that with each other? And this was the same problem also with the water problem. And I think that is a weakness. On the other hand, I would say we have to deal with the situation. And perhaps we as scientists, we have to put ourselves into the shoes of the stakeholders and would think, what would do the environmentalists favoring photovoltaics have as criteria? What would the lazy persons just focusing on fast cars and not aware of environmental topics, what would they like to do? And by that we have to assume what the stakeholders would think about. And in my projects, in each project, I was somehow frustrated that even in the project consortium, people had strong difficulties to understand the approach. They're mixing up criteria, alternatives, weightings, what is subjective. Then subjective is being said it's Willkür, it's that it's manipulative. But no, where you have to make a choice, then it is not. At so many points you don't have objective information, and you have to deal with that there is nobody around who tells me that terrestrial eutrophication is 3% more important than flexibility or so. This is a choice. And to explain that or to get a feeling for that or explain it, so far it was very hard. I tend to say it's impossible. No, it's not impossible. But this is an open question. And so to elicit the preferences is difficult. And for that, I would say, then we take some rough values or calculate that. And you can say, take the difference between the minimal value and the maximum and just calculate that. And then do as many sensitivity analysis as possible. And then the group of decision makers begins to understand the problem. And then you can start again. And that would be my proposal.
Just wondering, having Rüdiger also here and thinking about some earlier talks in that series where people coming from the finance community were talking about ESG criteria and portfolio management. Does any one of you two see possible linking between multi-criteria analysis applied to ESG portfolio choices, or as a decision support, perhaps not even for the portfolio managers, but rather for the people trying to evaluate the ESG performance of different companies using information which is also frequently incomplete, as we have learned in the last talk.
I actually see the greater problem in what you just mentioned at the end, that it's not even clear what our ESG criteria are to a large extent. I actually haven't seen anything on using the multi-criteria approach for this for ESG portfolios, but I don't know, maybe I'm not so much or not so deep in the literature that I have seen that, but I would say for portfolio optimization in finance, probably people have used that and have had a few criteria, but I mean, many things in finance are simply sort of below all the calculations, right? It boils down to a number you have, and so I think it's hard to have additional criteria. Although we now have sort of some soft criteria as ESG in the system, and there are some papers which actually change the utility function from being just sort of wealth dependent to having some sort of non-monetary utility in there. But that's a few papers I've seen. So yeah, that's probably all I can say to that.
Interesting to hear.
So I jump back to my role as co-host with Jutta. So I'll take the raised hands, and Jutta, you if you see somebody waving, you take over. But I don't see any Zoom hands currently. So I think then we could come to the end. So thank you all for participating here. Thank you very much, Jutta, for this very nice and illustrative talk, for your introduction of your research fields. At least I'm very impressed. So now I see myself, and I'll come back. So my head is back on. So as usual in the Zoom format, I said the last question I usually would ask the presenter is where do you want to go for dinner? But we have to sort of delay that for a little while, and I'm sure we'll have occasion to meet, and then we'll go out as a group, and you're on the dinner list for that. So thank you very much for the talk again, and thank you everybody for participating. We will have our next talk in January 12th, and it's a talk from a practitioner, Sascha Kohlenberg, who works for Define. It's actually a PhD student from the group, and he will speak on transitioning front office process landscapes, trends, challenges, and technologies. So it's a bit of a unusual talk for us. So we will speak a little bit about challenges from the front office to the risk managers in the back, something like that. That's at least as far as I understand it. And the last talk for this term will be on the 2nd of February, and then it's forecasting talk more in line of what we usually do here. But thank you all again for participating. I wish you a very sort of quiet time until Christmas, a very nice Christmas time, and then we'll meet again next year. So thanks again, and thank you, Jutta, for this very nice talk.